Hello, everyone. I'm unable to see the chat, so please chime in if you have any questions to me. Welcome to the San Diego C Meetup. Hopefully you can see my slide and you can hear me. This is our 55 meeting, almost 5 years into the since the inception of the meetup as it stands today. So for today, we have an agenda to take a look at the introduction to C++ in embedded, and I'll explain more when I start the talk, but that's basically the agenda. But before we're going into the main agenda, just the regular intro. Hopefully you can see the slides flipping. Let me know if you don't, but this is the intro. Sometimes for some reason it doesn't show that flipped, but hopefully you can see that, right?
No, we can't see it, and we can't comment. There's no,
So
the system will not allow us to comment. We can't comment, and we can't see it.
okay, so
we're locked out by Teams. Teams is locking us out from commenting. But I will speak, and I've spoken now.
I think,
let me speak.
Yeah, I can hear you. Let me reshare. Sometimes there are some issues. This is why I'm asking if you see my slides flipping. Sometimes there is some issues. I don't know why, but in terms of commenting on in the chat, unfortunately, if you are a guest, I don't think you can comment. I don't know if this can be fixed, but I'll take a look at that for later sessions. I don't think you can comment, but feel free to chime in if you need anything.
Okay, so just to be trying to be helpful here, it says KC, and there's a blue circle around it. There's no sharing, and if you could maybe see if there's anybody, see if anybody can see it. I don't think anyone can see it.
Colby, can you hear me?
Yeah, I can hear you.
This is Errol. I'm a new member and a guest. I see the slides and I see your picture. There's no chat because I'm a guest.
Yeah, but you can see the slide, the intro slide.
Yeah, any new members and we need you, call to talk, blah, blah,
okay. Okay. Yeah, so if for the person that can't see the slide, maybe you try to leave the meeting and rejoin. Maybe that would fix it. Okay, so I'll continue. Hopefully the rest can see the slide. If you are a new member, welcome. I'm happy to have you. We are meeting on a monthly basis to discuss all kinds of C++ related topics. I have a special speaker next month. I literally today confirmed that he's accepting that that would be next month. Very interesting speaker that I'm super happy to have him with us. So keep an eye on the announcement. If you would like to have a talk from like any size, from lightning talk to a full size 1 hour, 15 minutes, 45 minutes, doesn't really matter. Let me know. If you just happen to find something while you're working in your day job or just a hobby project, we all have these moments where we feel like we can share ideas and things that we learned. There's the language is so big and just getting bigger and bigger that it's really impossible to know everything. Just like Bjorn is saying that I think he's like 6 out of 10. So that's Bjorn. So so we can all learn, and that's basically the idea behind the meetup, is to share knowledge. Books, talks, anything that you would like to share with us, that's the place. So please approach me if you have anything. This is sponsored, which means paid by Qualcomm Wireless Research Software. I'm a Qualcomm employee. However, this is not beside the generous a part of a VP that I used to work for is Charles Bergen, which paying for that for the meetup fee, because meetup fee has the meetup organization has fees to host the page in their on their website. So Qualcomm Research is paying for that. But by all means, this is not a Qualcomm endorsed, and all of my everything that I do here is on my private time and basically not endorsed by Qualcomm. So it's just a disclaimer. My name is Kobe Koenarazi. I work for Qualcomm, as mentioned. I work in the cloud business unit of Qualcomm, specifically on the host software of the AI 100 card. This is an inference ML AI acceleration card. So that's basically my day job in Qualcomm. When we're done with this, like in every meeting, this is the Dropbox link. If you need the link, just feel free to ping me either through Meetup page or Discord or any like LinkedIn, anything that you'd like, and I'll send you the link. We have a Discord where I do announcements and other things. If you need the link, just let me know through LinkedIn or Meetup page. I'm uploading the recording to the YouTube channel. We have a YouTube channel, SDCPP Meetup, which has multiple past sessions. We had Conan recently. We had a lot of great speakers, so feel free to check it out. You can find me LinkedIn, Twitter. So I'm maintaining the San Diego C Meetup handle on Twitter. I'm also on Mastodon as well. I think the handle is the same, Kobe_CA. So feel free to ping me if you need anything. When I'm posting the recording to the YouTube channel, I also would have a small page posted in Vobot.blog. So Martin is hosting me in this in his blog post area, and I would have a summary of what we discussed in this forum in the past session. So so today is the 30th. Usually I do it on Tuesday. I was about to schedule it for Tuesday, and my wife reminded me that this is like Tuesday, which is tomorrow, is Halloween, and I better not have that scheduled in Halloween, which is completely right. But this is today was the last opportunity for me to have a session for October. The original session was a couple weeks ago, and unfortunately I needed to cancel that. Basically, this is my own personal tragedy. I lost my nephew in the first day of the war, unfortunately, and I needed to travel, support family, and I'm back to San Diego. This is basically the reason why I needed to postpone it, and this is a person that I deeply, deeply loved, and we lost him. Okay, let's have a shift into the actual main topic for today, more than C++. And this is basically kind of an intro session of targeting people that maybe have doubts about whether C++ is adequate or suitable for embedded environment. There's going to be various levels of the language presented here. So there's going to be some beginners, some intermediate, but not complex stuff, not too complex. I wanted to keep it in the intro level, and have people that thinking about C++ in low level and embedded, thinking about C++ in a more serious way. And the goal of this talk is to point out on things that you can use in C++, sorry, and the gotchas that you should be aware of. And we'll talk about that in details. I specifically saying more than C++ and not just C++, because more than C++ since C++11 is providing us a lot of new syntax. There's a tons of new syntax, and it's there's a major, obviously a major change in C++11, and we keep getting changes both in the language, the core language features, but also the libraries are getting better and richer and easier to use, but also it has complexity, and we need to remember more things. We need to be aware of more syntax and more libraries out there. As I mentioned few minutes ago, it's really hard to know everything in C++. So there are new semantics like R-value semantics and similar. There are new standard library. There is a new memory model, concurrency, threading, things that we didn't have before C++11. We have Lambda. We have more functional programming style, especially in the library domains. We get more and more ranges support and more FP, kind of a functional programming style adopted in C++, which is cool. There is kind of a hidden subset of the language that you can use today for your embed. So if you're not speaking, I myself 1 second. And try to see if there is anyone not muted. Okay, all good. Okay, I'm back. Okay, so there is a subset of language that you can use today for your embedded project, but you need to know what can be used, what is basically kind of a zero cost abstraction, and what is nearly zero cost abstraction, and so on and so forth. I have few stories behind people that tried C++ in maybe real time, maybe embedded, and got very disappointed. And the reasons usually is basically not knowing what exactly happening when they write something, syntax in C++, and also not being familiar with the feature. For example, I have a couple stories. One is a project that was an embedded project that was using C++, and when I asked what kind of features would you be using, and they said probably not, or definitely not Lambda, which I found it very strange, because Lambda is just a function, and compiler is doing a great job in optimizing a lot of things. So I think the syntax was scary enough for them not to use it. Another story is people using the standard template library, which is a library that is shipped with a specific vendor can ship that with your toolchain, and you need to know exactly what you're using. If you try to use something in the standard template library, like a specific container, and you're using it in a way that is not really suitable for your environment, it's not the language that is busted. It's basically the standard library is not a good fit for your environment, and you either need to maybe implement things by yourself using C++, or you can find different libraries out there, obviously vetted with legal for your company and all. You need to adopt a different, more suitable library that is a good fit for your environment. So if we think about why using C++ in embedded and real-time environment, and now I have a few references to other talks in a second, but just as a quick laundry list, class types makes organization of your data members better. It's easier to reason about if you do it correctly. Everything that I'm going to say is like if you do it correctly. Obviously, if you have a huge class with dozens of members, you're not helping yourself. But if you do it well and you have a small classes which are basically conforming to a single responsibility patterns, having some public API, some small subset of a private members or data or function member functions, then it's easier to reason about your data. It's easier to construct it. You don't have a special init function that you need to have. You can have everything done in a constructor, which is a special function in your data type. You can use namespaces to have logical organization of your code. It makes things easier to also reason about. If you do it correctly, you can have nested namespaces. Just don't overdo that, of course. And namespaces is basically, I would say, on the most part, zero cost abstraction is kind of organization. You need to be aware of the rules of namespaces, but it's a great way to make sure that you don't dump everything on the global namespace, and you can have data and functionality play with each other very nicely when C++ needs to match data with functionality. So there are some rules that happens, and namespace can help us. So I already mentioned that you should, in C++, since it's a very complex language, there's a lot of things that you need to know. You need to understand what is the cost of the line that you're writing. You can make a lot of extra work if you're not familiar, because in C++ there's many ways to, let's say, pass, not many, but a few ways to pass an argument to a specific parameter. It depends how the parameter is defined. And if you don't do it correctly, you'll pay an extra overhead that you don't need to pay, but you have the choice to do one or the other. This is something that C++ provides you. The fact that you pass something by value unnecessarily by value doesn't mean that the language has an issue. It's just you need to understand what does it mean when you write that. So this is a very common issue, because when you work with something like Python, maybe other managed languages, you don't need to think about this kind of, on the most part, you don't need to think about how you pass argument to function parameters. But in C++, you need to, if you want to squeeze most of your performance from your code. Yeah, let the compiler or optimizer do its thing. Write code in a way that helps the compiler and the optimizer do their job. If you have doubts about how things would eventually run, measure. Don't assume anything. And if you know about Compiler Explorer that was created by Matt Godbold, if you listen to one of his description why this tool was created, the tool was created because of debates that he had with his coworker about how a specific code would behave in terms of uh, generated code. So take a look at the code that is being generated, measure, use benchmark to measure. There's all kinds of ways to benchmark, or micro benchmark to something more than just micro benchmark, but measure things. But don't write the code in a way that makes it very hard for the compiler to optimize. Just goes back to what I said before. You need to know how to pass argument and write correct syntax in order to squeeze the maximum from the language. So things like const expr in C++ 11, const eval in C++ 20, better for constant definitions. They're better than pound define. The reason it's better than pound define is because pound define is a preprocessor thing. It's a search and replace. It doesn't play with the language. It doesn't care about the language. It doesn't know about the language, right? Const expr and similar knows about the language. So if you have a const expr defined inside a specific namespace, it is actually a nested type or name inside the namespace, while pound define is just a string that is replaced and it's not aware of the language. So const expr can give you the same benefit of pound define, but it plays very nicely with the language constructs. Templates are a huge advantage of C++, and we'll have few examples that can allows you to write smart code. It can customize types. It can basically provide you solutions that are zero. Some of them are zero, some are near to zero cost abstractions, and even the old fear of code bloated is getting better and better, and I'll show that in some of the future slides. But it makes code much better to reason about if you do it correctly. Using type traits and similar makes things run in compile time, like decision makes made in compile time instead of runtime, and it's a huge advantage. One of the things that I'm always thinking about when I need to deal with templates in order to improve runtime is if I know something that is happening in compile time that it is known in compile time, I make sure that it's resolved in compile time and not having an if else that is running in runtime and not is evaluated in runtime. So I see a lot of cases where a specific code is or specific type is known or specific expression is known in compile time, but instead of taking this advantage of and basically using it for our sake, people actually using if else that happens in runtime. And something similar to template actually goes hand to hand with templates is asserts in compile time using traits. So this is just some immediate kind of laundry list that should give you some idea of why and how C++ can be used. And most of the things that are here on the slide can be basically a zero cost abstraction. Basically, they are compiled as if you were manually doing like templates. You can mimic templates. When I say mimic, you're just duplicating code instead of letting the compiler do that. But eventually, you'll get the same code generated but with a lot of effort and pain if you do it in C and not in C++. This specific talk is heavily inspired by this book, Real-Time C++. So when I think about topics that I would like to discuss in this meetup, I look at books, I look at blog posts, and I really like this book. This is the fourth, I think today is the fourth edition. Yeah, it's the fourth edition of the book. It has a GitHub with code snippets that I'll be borrowing some of the code snippets and made some changes. But this is a great book. The last one is a C++20 book, and it's I think is a great book. Start from the beginner side all the way to the more expert side. A very thorough one if you want to see how C++ can be brought into embedded microcontrollers and similar. So if you're not familiar with this book, I suggest you take a look at that. Few couple talks that I would like to highlight and just call out because I think they are great and important. One is Dan Sachs, Extern C, talking to C programmers about C++ in CPPCon 2016. I attended this in person. It's a great one to see how we can discuss about C++ with C programmers. There's like two different communities that need to kind of discuss about ideas and how do we bring C++ into the C community. So that's one talk. There's another talk that I also had an opportunity to attend in person using C++ 14 and embedded super loop firmware by Eric. This is basically an interesting talk about having C++ implementing drones logic that I think this is Amazon the Amazon project to get the shipment through a drone. So it's a great talk. It's a talk about what they used in terms of C++ in their project that worked well for them, and they're basically using C++ 14. Okay, so let's start with a quick example and make some comparison. So this specific simple code is a class of LED. It's very simple. It's written in more than C++. You can see this using, you can see explicit, but it's very, very straightforward. You have a port type, you have a bit val type, which are basically uint 8. There is a constructor. There is few expressions that using volatile. Yeah, volatile is something that you can use in C++, just like in C. Just use it in the places where it makes sense. Don't use it for synchronization, but use it to tell something to the compiler regarding optimizing out and similar. So volatile is perfectly valid. And there's nothing fancy here except just few expressions, and there is a toggle function. The function is const, so if we have a const function, we can use this function. No except as just not throwing in exceptions. And there are a couple members that are uint 8 type, and the main would just call the constructor by having this port type and just the bit val type and just calling toggle. So that's one way to use it, and it's perfectly fine. We can take another look at a more advanced way to use it. and using templates. Why using templates? Because we can, and it fits very nicely for this use case. Obviously, this is just a minimize example, but you can extrapolate that to something bigger. But make sure that your class types are small so you can reason about that. The idea behind this templated version is that when I'm creating the instance of the LED class is the template class. So I'm passing the types of the port type and the bit file type. Both of them are uint8. And then the values themselves. Yeah, I can do that because I can have integral as the template parameters. The interesting part here is that this the size of the LED is much smaller than the size of this LED. The size of this LED would have uint8 times 2, and the size of this LED is basically just might be 0, it depends, might be 8, it's just not including the uint8 the 2 uint8 that we have here. The static const expert this is a const expert that is resolving compile time, and whenever I'm using pdir, which is here, it's just replaced by the port -1u. That's all. And I can do toggle, and I'm getting the exact same effect as this one, but with less footprints, because I can do that here. Now, if I put it in Compiler Explorer, so this is the LED, the first LED. This is the generated code with optimization on GCC 13.2. I just picked the default back then when I created the slides. And this is the LED template. Well, if you just pay attention, they are both exactly the same. So there is no difference. And if you were thinking that, okay, templates might be bloated, might have some runtime cost, you can see that the code is generated exactly the same. I must say that I'm working with C++ for 25 years. Compilers getting better and better in emitting code, which is optimized very nicely. Now, if I'm looking at the size of the LED and the LED template binaries, this is what I'm getting at the top part of. So you can see that they are pretty much the same. The actual ls-la is the template of is a bit more in the same of CPP. That's a CPP. That's a text file. So it's like more characters on the text file. And on the disk, the LED template for some reason had a bigger payload on. I haven't looked at the actual binaries to inspect it more. I just stripped both of them, and both of them went down to the same amount of bytes on the disk. What I'm trying to say here is that just an example, and this example is taken from the intro of the book with some modification that I've done. Templates are a great thing to have in your toolbox to use if you want to make if you want to write code that use a lot of constants. You want to write code that might have different types, depends on the platform. And this is something that usually when you write code that is targeting multiple platforms, you want to have it flexible enough. Templates makes a huge improvement in your workflow if you use it correctly to port it into multiple platforms. Okay, so I mentioned about a subset of C++. Let's discuss that. We want to identify a subset of the language that is suitable for real-time domains. I would say that C++ has a lightweight components. I would say components, basically features of the language, specifically the language. We talk about the libraries it's a different bullet, but the language itself has a lot of new constructs, either existing or new constructs from C++11 that allows us to do manipulation that is suitable for real-time domains. Again, you need to understand what you're doing. Lots of the things are easy to use, even for beginners. I'm gonna show multiple items. Some of them are very easy to understand. Some of them will be on the more intermediate kind of thing, but it's kind of a list of things that people coming from C would do it differently, and in C++ it makes sense to do it in the way I'm presenting. Just to reiterate about libraries, make sure that if you're using libraries for embedded and real-time domains, you understand what the libraries are doing. You need to read documentation. If you don't want to make allocation, you can't really use containers, for example, that make allocation. And even some of the standard library algorithms would do allocation. I think stable sort might be allocating space. So you need to consolidate documentation in order to make sure that it's really makes sense for you to use it. If it doesn't make sense, there are obviously GitHub.com has multiple solutions that might be suitable for you, both on the practical part, but also legal wise, it would be suitable for you. Declare variable close to where it's being used. There are a few reasons why. First of all, this is not super helpful because result is not initialized. Why having result at the top of the scope and then used somewhere at the further down? Why not having it in the same location? Now, there is also other reasons for that when we start talking about C++ classes. Why do walk before you actually need that? Maybe you return, maybe you throw if you can throw. So why create walk? Why do walk before you actually need the walk? So because if the constructor is doing some work, why doing it before you're actually using it? So declare the variable, define the variable close to where it's being used is a good guidelines to have. Speaking of guidelines, by the way, there is a core guidelines on that Bjarne and Herfsader are maintaining. It's a good starting point, although it's not a small document, it's a huge document, but it's a good starting point to align what you should do with C++ in order to get it maintainable and in a good shape. So know your integral types. cstdint, which is basically the C++ file for stdint.h, has multiple macros that you can use. The book that I mentioned, the real-time C++ book, is using these macros a lot. This is exactly 16-bit sign. This stood in 16T. And this is a uint 32 macro, and there are separators here. The macros might use literal suffix like the one that I'm specifying here. So it might be easier for you to just use the macros and let the macro do its thing related to adding the literal suffix, doing it for you. uint list 32t. This example just gives you another idea about a type that your platform would pick. In this example, would pick the smallest unsigned integer type with the width of at least 32-bit. There's also 8 and 16 and 64-bit, but in this example, there's a 32. So this is a great way for you if you want to denote, I need the smallest unsigned integral that has at least 32 bits. And that the platform would pick whatever is on the platform that would be accomplishing this. So if you don't use the macros, you can have view, but it's not portable. So think about an example, and the example is actually here. Let's say that your integer on your platform is a 16-bit or maybe 8-bit. So unsigned int would not be large enough to hold this value, right? But a better approach, this is why the book is advocating using this macro, which makes it portable, is saying, look, I would like to have a uint32 that is can accept that one. And the macro would handle the values that can fit into 32-bit. So the first line is non-portable, because if your integer is not 32-bit, it's not going to fit. But if you use the macro, your platform will take care of that. This is why the book is advocating for that. Because you might not have the proper width for you to fit this number. So that's basically something that the book is advocating for, and you need to make sure that you use it in order to be portable and error-free. C++ has Boolean type. It's a great type to use for true and false. It's a built-in type. I know that C also has it, but long time ago it did not. Good for anything from just return type, ternary operators, everything. So that's easy to use and should be used. Yeah, there's a huge discussion about should we use integrals instead of Boolean and all, but that's a discussion that we can have. Basically, in some cases, you probably want to use something other than just integrals to denote a success with a value versus there was a failure. I know that C is using negative values for that, but sometimes negative values are a valid result, and you need to know how to express that both as a value plus an error. So there are ways to do it in modern C++ that makes it a bit more expressive. As I mentioned, namespaces are a great way to organize your code. It's something that should be used in C++. It's easy to use. You can see that I can have, so this is the definition. I can ask for outer F. I can have outer inner G. I can bring outer inner to F and call F, and that would call inner 2 if I want to. And this is using declaration is within the scope of func. I can have more of inner one in a different file, which makes it very convenient to have this my code structure in different files, but under the same logical namespace. And there are also anonymous namespace which behaves like static in terms of linkage in your compilation unit. Let's talk about basic classes. as a C programmer, I think one of the first things that you would like to pick up is using classes correctly. There are so many blog posts and also uh, uh, talks about how to use classes correctly uh, in a way that they are not behaving like struct. There's all kinds of uh, blog posts and books about getter and setters. Is it good to use getter and setters and all and similar? Uh, so the idea behind classes is uh, basically giving some API, have the data structure close to the API in some logical form, but also hiding from the user from the user of the API things that the user should not be using. Now, yes, you can do similar stuff with C, just the syntax looks a bit more nicer with C++, but you can do something very similar with C. That's basically my opinion. It just the syntax looks nicer with C++. Um, C style classes, or say C style classes, this is exactly what I'm saying. You can write classes with C in some sense. But C++ gives you our AII, which means you can have a constructor and then a destructor at the end of the scope, something that you don't have in C, though I've seen all kinds of I don't know if it's already approved, but I've seen plans to do something similar in C, like kind of an RAII kind of a thing. Uh, Make sure that your class has few data members, uh, few simple member functions. Don't create huge classes. Make sure that they have a single responsibility, and also make sure that you have kind of a downstream uh, programming in the sense that your class doesn't need to expose the data structure outside. That's the getters. You need to be easy with the getters. Don't overuse getters and expose containers that are data structure inside you as the members. Instead, let the class get information and do whatever it needs to do with the data structure, maybe providing results back. But the more you expose the internal of your data structure in your class, uh, the harder it is for you to iterate and refactor your class, because people using your class rely on internal representation of your class. And this is something that you don't want to, because most of our issues in spaghetti code is interaction between objects. That's most of the issues that we have in spaghetti code. If you decouple it, make sure that you don't expose data structure, internal data structure. You make it very easy to maintain it in the future. One of the things that I see, especially for people that coming from other languages, maybe C, they see inheritance as a feature of the language and they inherit a lot. And they're using virtual a lot, virtual structural, virtual functions, as if virtual is something that is mandatory. And I hear it a lot that people mistakenly thinking that virtual is kind of a mandatory when you have classes and when you have inheritance. Wait, when you think about inheritance, especially public inheritance, wait. Think if this is something that really needs to happen. Think about is a principle. Think about uh, the proper guidelines about inheritance. Yes, for polymorphism, if you do it correctly, if you have a pure interface, polymorphism can be a huge advantage when you need to work in a specific abstraction level. And I like to do that, but it's usually a pure interface and and then minimize API. It's not a huge API in the base class. Just use it when you need. Virtual functions, you start paying space, you start paying runtime. It's not a huge uh, penalty, but it is something that you pay. And if you don't need that, if it's just redundant, then why paying it? So that's basically just remember that this is basically something that you should be aware of. So let's take a look at basic classes. So there is a point. There is a uint 8 which is initialized. So basically, I don't have I just have one constructor, which is point, which has default values for the parameters, 0 in this case. Pay attention, I'm following the book, the real-time C++ real-time book guidelines. I'm using the macros in order to be compliant. And then I'm just initializing X and Y. And I have some function. It's a const function, which means that if I have a const object, I can invoke this function. It doesn't change the members of the function. This is why constant it's a no except, because I'm not throwing anything from this function. And just doing some computation. Auto is used here because the compiler has full visibility of what is the type that's being returned. By the way, the type here is int. Whatever the width of the int in your platform, but it's int because there are integral promotion happening in x2 plus y2. So it's in integer. And I have a small main. And main has a const point p1. So this is something that happens a lot in codebase. I know that my p1 will be 0 and 0. And I have a p2 that might be 10 and 20. And it is known when I'm constructing the object, and it's going to be const. Since p1 and p2 are const, I can use it with a const function. If the function was not const and p1 and p2 are const as I have it here, I wouldn't be able to use. So fortunately, the member function is const, and since I have const objects, I can invoke const function. And I'm just having just a simple computation and just returning the sum of it. If you compile it, now I'm using CLine and Compiler Explorer plugin. So CLine in the recent, so CLine is an IDE by JetBrains, which I'm happily endorsing. Like, I really like that IDE. So my opinion is that you should try it if you don't. If you didn't try it so far, it's a great package. And I think it increases productivity. Anyway, they have this show assembly that it's a new feature that they have, which you can basically open another frame, another tab, and it shows the assembly, generate assembly code. They also have a Compiler Explorer plugin. So this is a Compiler Explorer plugin, which just gives you the two instructions, the move and the return. This whole thing is compiled to in Compiler Explorer to this two, and this is the whole dump of main. But basically, it's basically the same as it's just a different way that Compiler Explorer presenting that. This is with all that string, that long, all of that is happening here, but main is really, really simple. Now, how does it look like? How C++ class would look like under CPP Insight? So this is how things would look like if you paste it here and just hit play. This long line is basically how the compiler sees this whole static cast and all. As I mentioned to you, since there is an integral promotion with UN16 being forwarded to an integer, the auto here is an integer. If you have doubts, I wish the IDE would give us that information, but if you have doubts, just put it in CPP Insight and you'll see that. So basically that's how it looks like. Now, if I need to have a C version of that code, I have a struct. It's basically very similar. I don't have a constructor, so I have an init just to initialize. So this is how it look like. Inline is a must, otherwise. So this is without an inline. This is how compiler explorer sees that, and this is how it's basically compiled. This is when inline is applied. So because what happened is that in the C++ version, it's all implicitly inline because I defining the functions, the constructor, and this single function inside the class, so it's inline. So in order to match it to the C version, I better have it inline. Just for this example, you can see that it's basically generated the exact same code, but this is C. This is C. I have a struct of P1 and P2. I'm initializing it, calling the function, passing P1 and P2, and basically getting the same result. So the bottom line before we go on to templates is that you can achieve exactly the same code if you do it correctly and you know what you're doing. So that if you don't get an expert or someone that is an expert in your team in C++, so this person can help. But you can achieve the same idea, but with instead of calling init, you have a constructor, which make things a bit cleaner. And I can have point as a one type that has associated API plus associated data member in one construct point, versus in the C, I have a struct point and I have associated functions which are maybe in the same file, but they are not. The only way to understand that they are part of the interface of point is because I need to pass the struct point as a pointer in order to either get information or manipulate things of point. So it's not, there is no like strong correlation between the functions and the struct. So that's something that I think makes life easier in C++. Let's talk about templates, because templates are heavily used in this book that I mentioned, the C++ real-time book. Why? I think one of the things that they want to convey is that if using templates in the correct way, you can achieve a portable way to compile your code in on the different platforms and achieve the same same goal, but the compiler and using templates achieve different different code that is suitable for your platform. You write the code once and you can instantiate it for multiple types. You don't need to maintain multiple instantiation of that happens behind the scenes by the compiler. You can do a lot of smart checks to make sure that the types in compile time conform to a specific either logic or maybe assumptions that you need to do in your platform. For example, you need to make sure that on your platform, the size of this type is a specific number. Otherwise, you don't want to do something, or you don't want to deal with it, or we want to have compiler, or that's an easy way to do with templates. Keep the template small, keep complexity low. Templates are inline by default. How templates would look like if I instantiate templates with integers and then double. This is how, in the guts of the compiler, how things would look like. This is again from CPP Insight. If you have doubts, you can always use this tool in order to see how things would look like. So this is the template definition, and this is an integer, and then double how things would look like in the guts of the compiler. I don't need to maintain this multiple instantiation. I just write it once, and the compiler is doing the heavy lifting for me. Traits in templates are a great combination. I'm not showing here CPP+20 concept, but here's a very nice examples. Let's say I have a function that says add, and I'm adding integrals, and I have adding doubles. So adding integers and doubles. And I can even add strings. But let's say that I would like to make sure that my function only works with integrals. So I can have a static assert, making sure that when I compile it, the compiler would instantiate the type. So in this example, I'm static asserting, this is happening in compile time, that t, that is the template parameter, is basically an integral. If it's not, I'm going to have a compiler, or in this line would fail. So namespace with traits, it's the same name but different namespaces, would not compile. Let's say I don't want to add strings, or I just want to add something that is an integral. That is a nice trick to have, and C+20 with concept might have a better syntax than static assert. This is a simple thing to remember, because I'm seeing it a lot, that people using null instead of null pointer. It's just a better way to denote a type, which is a pointer, and is null. No conversion to integral, no pound define of null. Easy to remember, use it. Remember, I mentioned const expr in the beginning. It's a better than pound define, and this is just a few examples of how to use it. I'm still seeing people coming from C using pound define, but this is a better approach because, again, it plays nicely with the language. If this const expr is inside a class or is inside namespace, the language understands this name is nested within a specific namespace or with a specific type, which is basically can be a class or a struct. So use it. This is a zero cost. You place it in Compiler Explorer, or you take a look at the generated code. You'll see that this is not taking anything, and it's basically a good idea to use instead of pound define. The one thing that const expr is super helpful, and this is a huge topic by itself, is shifting computation that you can do in compile time from runtime, shifting it into compile time. So the book has multiple examples where on some microprocessor, I have these tables or I have this array, and I need to, on this microprocessor, I have to do some manipulations or maybe computations that I can do on this constant table or array. And instead of doing it in runtime, I can do it in compile time, and I can have the result of this computation placed in a const expr variable, and I'm shifting maybe initialization part, maybe anything else from runtime into compile time. So that's a huge improvement in modern C++. So here's an example. I have this array, which is an integer, 3 integers, 1, 2, 3. I'm passing it to get to x. which just take the size times 2, and this is the size. So there are multiple examples in the book about real life examples about how const expert function can be used to compute something and then placed into const expert variable. This is guaranteeing that everything is const expert and makes our life much easier and much faster, obviously, because it's you might pay in compile time, but you're reducing overhead in runtime. So that's a nice thing to do. Again, type traits are a great thing to be aware of. Compile time assertions, also something that you should be aware of. Don't use magic numbers, use limits. There is a talk with Dan Sachs about integrals and limits. This is something that you should be aware of. This is just an example of things that should be used. And this is an example about how I can use a const expert, something that is known in compile time, about how many digits I have in integers for this specific platform. And I can assert, maybe I need to assert that for this specific platform, I need, or I expect 31 digits of integers, not including the sign, obviously. I can query the platform about in compile time about the maximum number of the integer, the maximum value, the max int. There is a max underscore int, obviously, but this is the C++ version of, this is basically a template with functions in the template class. And I can make sure that if I do some casting, it's being done in a right way. There's obviously more things that you can do with that. There is a Stack Overflow that shows how to do a proper casting using numeric limits. Just an example of how to use it correctly. If you think about containers in your embedded environment, std array is basically a CRA. It's just a CRA, but has few advantages that you can think of compared to a simple CRA. First of all, it has a copy semantic. It's safer if you don't want your pointer to decay to, you don't want your array to decay to pointer. You can pass an array by reference easily. Has some const expert semantics, so you can do some stuff in compile time. It gives you a begin and end. It is an aggregate, by the way, so that's a huge thing to remember. And it has all kinds of functions. It has a size, it has all kinds of iterator-like functions. It works very nice with span. I'll show that. I can return that with copy semantics. So it might be a better approach compared to a C-style array, though I'm not precluding C-style array if you think that this is something that you want to use. Here's an example. I'm passing by value. There is no decay of the pointer of your, if it was a CRA, it was decaying to pointer. I can pass it by reference. I can return by value, which gives you a copy semantic. C++20 has all kind of functions to create an array. So this would create a std array of integrals of 4 elements. There are some other experimental functions to create an array, which you can use as well. So this is under experimental array. You should be aware of STL algorithms. You just need to read the documentation if it fits your platform. Using algorithms makes life easier in terms of readability. So you need to make sure that you familiar with the things that are out there for you to use. I'm just listing a few of them. Some of them are zero cost, and I'll show an example. They are zero cost. They are as if you were writing for loops, but instead of for loops, you're writing something that has a name. Okay, so max, accumulate, all of, any of, none of, for each, copy, remove, transform, all of that you should be at least aware of that. Read the documentation if it fits your platform. Numeric is one header. There's also algorithm as a header. Numeric has accumulate, inner product, and some others. So it's kind of confusing. Some of the algorithms are in algorithms, some of them are in numeric. Just be aware of them. Let's take a look at a few examples. So I have an example of function that takes an array, just fill the array with the number 17. I can put anything. I can put 0, 17, 42, just whatever I want. Okay, so it's an array, it's a C array, 10 elements, U in 32. I'm just filling it with 17 instead of having a for loop. Then I accumulate. And there is an assert. This is a runtime assertion. I can check if none of them is 0. So I can do all kinds of things. And this is how it looks like. Again, this is CLion with assembly, show assembly feature, which is available in the latest versions of CLion. So this is one example of fill, accumulate, none of. This is an example of fill and accumulate, again, with the assembly code. Now, if I'm taking this example and comparing it to just a regular, it's still C++ because I'm using std array, but it's just for loop. So imagine that what I'm showing you here is a C code compared to C++ using algorithms. It's just a C code, right? It's just a std array. I could have a C array. It's the same idea. And if I need to compare the two, if you inspect the code that is generated, it's exactly the same. My question to you is, what would you like to see in your code or your peer's code when you read something that you need to maintain? Would you like to see something that calls fill, where I know that fill is basically filling the container with a specific number, and I don't need to think about indices because I have a begin and end? And accumulate, where basically accumulate says accumulate. I'm accumulating. This is I'm accumulating starting with 0 is the first initializer. I can have 10 if I want initializer to be 10. Versus a for loop that I need to reason about. I need to make sure that the condition is correct and everything is correct. I would vote for this. Maybe others would vote for that. But I personally would like to see a shorter code that is more expressive, especially if the code is generating the same assembly. I'm not talking a lot about the memory model, but you need to be aware that the memory model is introduced in C++ 11. For example, atomics, atomic load, atomic store. This is an example of just an atomic operation. So I would suggest that you at least be familiar with atomic operations that are provided by the standard and what your platform, on your embedded platform in the toolchain, is providing for you. The digit separator is a convenient. I already talked about it, so I'm not gonna explain more. But just a convenient way. Has nothing to do with embedded or not embedded C or not C++. It's just a convenient way to do that in C++. Maybe C has something in a more recent versions of C. Maybe it has something similar, but I'm not familiar with that. User-defined literals so there's literals and user-defined literals. Quickly about just the literals. This is again zero cost abstraction. 0b1 is a way to say just 1 bit, and if I want to express more bits, 0b, and then I'm using the digit separator to say 7. It's a very convenient way to do. I'm still using UIT8C as a macro. Let's talk about user-defined literals because I think it's a nice feature, zero cost abstraction on the most part in C++. User-defined literals allows you to have literals that you define cell. For example, I have inch, foot, and yard defined as literals that I can have as a suffix to my integrals, double, whatever. So here's how it looks like. I have these literals that basically I can attach to any of the numbers. So when I have 12.0 underscore inch, the compiler has a magic where it would call this function and create that. It's inline, so everything is nicely optimized. And this is you can see that this is how the code is being generated. There is nothing extra that is being done. Even if I was using it, obviously I'm not using it, but even if I would just return the sum of all of the values, you'll see that it's all zero cost abstraction. But it's nice because what I can do here is basically I can actually create a type that is being returned from this literal, and I can have 100 underscore foo. I'm creating this auto is basically a foo. It's a strong type that is created by 100. So if you think about it, there is a foo that has it's a struct or a class. You can have a class that has a value which is 100 in this case because I'm creating this foo here, and I can just do that value. It's zero cost. I'm returning 100, but my foo is basically a strong type. It's not just a number 100. So I cannot mix different semantics of types with each other. And this is really nice way to create units, to create strong types with user-defined literals. It's one of my favorite uh, features in modern C++. You have more literals that are defined, like string literals, chrono literals, complex numbers literals. So be aware of to uh, uh, have it to check your platform with all the literals that you can use. Alignment, you can query alignment in compile time to make sure that it fits your platform. So a line of something will tell you the alignment of the type. Might be different in different platforms. So if you need the alignment, if you need to query the alignment, you can do that. This is kind of an portable way, not specific intrinsics of your compiler or your toolchain. There's also a standard way to align something to a specific size. For example, I want to align this struct to 128. Again, it's a portable way instead of a specific intrinsic. And I can check that it is aligned or not in runtime. It's a very convenient way and used a lot in some code that demonstrated an advantage if being used this way. I want to highlight the final specifier that you can put on classes, structs, and functions that allows us to tell the compiler this is a final class that you cannot derive from. This is a final virtual function. So there is no other virtual function in derived classes that overriding it. There are blog posts that shows that in some cases this can the compiler can take advantage and devirtualize a specific function because it sees the final. So it depends on the use case. But I specifically use it if I think that this is a good idea for a specific class or a specific virtual function. So I don't want anything derived to override it. And again, can be very useful for the compiler in terms of optimization. Span is one of the library feature in C++20 that a lot of people love. I specifically like it a lot. Bjarne also endorsing it, promoting it a lot. Introducing C++20, I think one of the important library additions. GSL, the guideline library, is also containing this class type. It has multiple constructors, like I don't know, multiple constructors. I can't remember, but at least a dozen of constructors to adapt to all kinds of containers, CRAs. Here's just an example of a function that takes span. Now, span is basically a container. It's a non-owning view, just like a string view. So a string view is also a non-owning view for strings. Uh, Span is something that you can actually, although you non-owning the view, you can actually even modify the view because I don't have a const on studbyte. I can actually modify each and every element that I iterate. So it has a iterator-like semantic, and instead of passing in C, we usually pass a pointer and a length to a buffer. Span is a great way to get rid of this habit and use a uh, one syntax or one class to denote a pointer and a length to some storage instead of passing it in two different arguments to do two different parameters. So there's something, again, something that is endorsed by a lot of people, including Bjarne. And if you have doubts, don't. Just put it in a place where you can measure either runtime measurements or first order looking at Compiler Explorer or in CLion, the show assembly. So just don't be afraid to measure before you decide that this is not suitable for your use case, because you might be surprised. I have a small story where span was actually improving code versus using just pointers. And this is something that I used to work with Jason Turner on that. He helped me on optimizing it. Actually, the span idea was his idea to get things faster. Just make sure that you use it when it's appropriate. It's gonna make your code at least more maintainable. So I'm reaching towards the last 5 minutes of the talk. There are lots of topics that I'm not covering, obviously. I'm just listing some of them, just gonna go over the list very quickly. There's pseudo-random number generation that's being introduced in more modern C++. I also mentioned using, instead of typedef, just a nicer way to write your code. There's no runtime implications. You need to think about cache-friendly containers when you're using C++ in embedded. Again, the fact that you're using some container that doesn't work well for you doesn't mean that the C++ is busted. It might be that you're not using the container correctly. So if you're using a container that makes a lot of allocation as a tree, maybe you need to have a flat map or something similar in order to have a contiguous cache-friendly container instead of something which is a node-based and sparse and not very cache-friendly. So make sure that you're blaming the library, not the language itself. Explicit keyword, I already showed that. It's just to avoid accidental and implicit conversion, which is important because you don't want to make accidental copies. So you need to be aware of this keyword. I already mentioned inheritance. There's multiple solutions that can provide you better performance with inheritance. CRTP is one of them, templates, static polymorphism with templates. You need to be familiar with at least patterns. And again, if you need material to understand how to write C++ in a better way with patterns, there are books that are being written that I can point you to. Const methods I already mentioned. There are things that I'm not touching, like variables that are also templates. The book that I mentioned, the real-time C++ book, has a chapter about inspecting assembly, using objdump to inspect that. using map files that are linker generated. All of that is being discussed in the book in a more detail, so I suggest you use it. You might need to use OpJump and others to take a look at what you have in your binary. CPAPA's filter is being used to demangle, so use it when you need to look at the symbol without the CPAPA's mangling. Yeah, the book also mentioned that you can use assembly programming, though the disadvantage is that when you write assembly programming inside your CPAPA's code, it's most likely not going to be a portable way. Check if your compiler or your toolchain is doing enough for you before you opt into writing, like manually writing assembly code that is embedded in your C++. There's also placement new. There is a polymorphic memory resource in C++17 that can help us to do better job in terms of managing memory. It can be a huge advantage in terms of speed. You need to be aware of that. Simon or Simon, I think the better way to pronounce his name, has a blog post that talks about PMR a lot, so check it out. Make sure that if you turn on RTTI, you understand that you pay some size and runtime costs. A lot of projects would disable RTTI to not to incur this overhead. So this is something that you can consider. Think about creating classes to address a gap where you need a big integer representation. There are libraries out there that you can take a look at. And before we finish, this is basically the last couple of slides. I wanted to show something which just gives you another taste about how C++ with templates can be easier is always relative. When you need to do something which might looks a bit more complicated with C, try to think about C arrays, constants that you need to do something with them in order to iterate and similar. So here's an example. The standard library has a template named integer sequence that it's a variadic template. The first template parameter is the type, and the rest are numbers. Let's say in the case of integers, are just numbers. So here's an example that I'm creating a class. It's a template class. I'm instantiating it with 1, 3, 5, and 7. And I want to sum the whole numbers. So I have a function that is a const expr. So everything here would be a compile time evaluated. Everything that you see here on the screen. So sequence accumulate just pass this class, just an instance of the class, right? To this function. So this is the function that takes an integer sequence, a student integer sequence, which I told you it has the first parameter, template parameter is a type, and some number of integrals. Okay, so I and that dot dot dot. I'm not explaining what is variadic template, but just imagine that this is expanded by the compiler to accommodate 1, 3, 5, and 7. I have a sum that is type of int type by the template. It's just 0 initialized, and then I just iterate over these numbers that I'm creating here, just a list, and initialize a list of 1, 3, 5, and 7. I just sum it. It's returned. It's a const expr function assigned to a const expr variable, and I have a static assert, again, compile time, it's not a runtime assert, that validate that this is a 16. And this is how it's going to look like if you expand an integer sequence, if you want to take a look at how integer sequence would look like, it's basically it's a template parameter of all these numbers. This is just a helper function to create a series of numbers. And again, the book is showing all kinds of examples that are real life examples about all kinds of map files, constants that you need to make some manipulation, and it varies from one platform to another platform, and you want to shift some computation that you know the data up front in compile time. You want to shift that computation into compile time and not doing it in runtime, because I could do this loop in runtime and would have the same exact effect, but it's going to be computed in runtime instead of compile time. Maybe that's something that I don't want to do. So that was my last slide. Thank you for sticking. I know it's over hour and a half, but hopefully you had a taste about how things can look like in more than C++, in a more constrained environment. Again, it's an intro type of a talk, but I do hope that if you take bits and pieces and investigate it yourself, you can extrapolate it and do some more research on your end to get it done for your projects. Do you have any questions, Dewey?
Yes, I have a question. Thank you for the talk. Early on in the talk, you said something that I was confused by, and then you said it again, and it has to do with these macros, these C macros. So we have uint 16 or whatever in C++, but you said that we should use these C macros, and it sounded as though you were saying that somehow a large number that doesn't fit in a 16-bit integer in C++ somehow would fit into a 16-bit.
Okay, let's go.
I mean, it just.
Yeah. I know what you're talking about. Let's take a look at that.
Thank you for addressing it.
Okay. It was this one, right?
Yeah.
So okay. So when I say u, it means unsigned int. Okay. Now I'm thinking, let's say I'm thinking, okay, this is an unsigned int. I'm coming from a 32-bit machine, and this should work in a 32-bit machine. But let's say, because I'm coming from a 32-bit machine, and I'm in my head, I'm thinking, so u is an unsigned int, and I'm thinking this definitely fit into a 32-bit, and this is correct. But the problem is that is unsigned int, it is a 32-bit on a different machine. So let's say, let's take the extreme. An unsigned int, an integer is an 8-bit on my platform. So I'm creating this number with a u, which is an unsigned int, and it's an 8-bit. Now, this number is not going to fit. In this platform, it's not going to fit. So this whole number, when I write it, the fact that I have u32 here is irrelevant, because when I have this u, I'm actually saying this number is going to fit into an 8-bit. I don't, let's say I'm completely clueless about the platform. I don't even know that it's going to be 8-bit, that I'm actually working on 8-bit. So but I'm saying that it's an unsigned int, so I'm having this u. A better approach is saying, look, I forget about the unsigned int. I need to fit it into a uint32c. So this is this is more portable than having a u, because under the hood, this uint32c would have the correct literal that would make sure that it would fit into 32-bit. So there is u, there is ul, and there is ull. So I naively can say it's fine. I can just have an unsigned because that's going to fit. and then I move to an 8-bit integer, and unsigned is not enough. I need maybe ULL in order to fit that. So why? So this is not portable, and this is more portable because I'm saying let the platform attach the right postfix, the literal. I'm not deciding on the literal. The platform header with the uint32_c would decide on the literal. So in other words, this is, by the way, this is something that while I was preparing this talk, I learned about it. Because I never thought about this. It's a subtlety. I never thought about it, and hopefully my explanation makes sense to you that the uint32_c, the macro would do the right thing in terms of the attaching the literal.
I'm sorry, but it doesn't at all. I'm looking at that second line and I see something that says stood uint 32t. So maybe I'm foolish, but it seems to me that that machine, if it only has 8-bit ints, you can't have a stood uint 32t. Maybe there's some weird thing where it'll make multiple bytes. I've got one variable and it creates some weird multi-byte monster that I
understand. Yeah, I understand what you're saying. So that's basically my thought as well, that the platform would provide me a type that is a uint32, basically a type that is a 32-bit. But if you just try to ignore this part, because I know it's confusing, and just focus on that one. This one is saying I'm going to have an unsigned int for this number. The question is, would that number fit into an unsigned int on this platform? What if the unsigned int is 8-bit? This line, forget the left part, the left side of the equal sign. This line says, I'm taking this number and I want it to be in the width that fits into, let's say, 32-bit. Platform, please attach the correct literal for me. I don't know what the literal is, but I need a 32-bit. Actually, I could put here auto if I want to make it completely agnostic and let the platform figure out their actual type that is going to be deduced in compile time. I hope that makes more sense.
So what you're saying is that I was correct, that there is the compiler will create some strange data structure that I don't understand and somehow make an 8-bit machine do 32-bit calculations. That's what you seem to have said. So thank you very much.
That's the only explanation, right? The thing is, it's most of us working, a lot of us, was also people working on weird architectures, but lots of us are working on some standard architecture where integer is a 32-bit, and so we don't even hit these issues. The book itself advocating for that, because the book itself is trying to address all kinds of weird architectures.
Good.
That's why.
Thanks very much. That's very interesting. Appreciate
You're welcome. Okay, thanks everyone. I'm super happy to have everyone. I'll see you next time. I wait for my announcements in a couple of days. I have a special guest for November. Thanks everyone. Take care.
Thanks. Bye.
Bye.
Bye.